All right, so we're going to look today at finding the average value of a function on an interval. So the graph above shows the velocity of a car as it travels down a track where v of t is measured in feet per second and t is measured in seconds. We're supposed to find the average velocity of the car from 0 to 60 seconds. Okay, so average velocity from a purely like non-calculus standpoint, average velocity. So let's think of average speed, because velocity of course has direction, so that changes things a little bit. But let's say that we're driving from here to Winston and we want to know our average speed for the whole trip. What are we going to do? If from here to Winston is, what, 30 miles, and it takes us 45 minutes, or 0.75 hours, right? If we want to average velocity, we would just do our distance traveled divided by the time that it took. Or we could think of it as our change in distance over our change in time. So we know here what our time is, right? We know it's 60. How can I find the distance that this vehicle traveled? What do you think? So this graph is velocity. It tells me how fast the car is going. It does not tell me how far the car has gone. How do I find how far the car traveled? What? Area under the graph. So if I integrate this, it gives me the area under the graph, right? And for this particular one, you got a couple options. It's linear. You could do the equation, or you can that distance it's our integral from 0 to 60 of v of t dt, and we can just do the area of that figure, which this is a trapezoid with the bases are, this is kind of like on its side, so the bases would be these two parallel sides, and the height would be 60, so it'd be 1/2 times 60 times the height of this shorter side right here is 70, and the height of the longer side is 130. So that's going to be 30 times 200, and that is going to give us 6,000. Is that right? Putting the right number of zeros there? I think so. Okay, this is my distance traveled during that time. Right? So that is the distance that I have traveled. If I want to know average velocity, I'm going to take that distance and I'm going to divide it by the 60, and that is going to give me 100. What are we measuring this in? Feet per second. Oh no, this broke. I'll lose my pen if it's not connected. One day, before I had this little bungee cord, I did lose my pen, and I was pretty sure that my class had stolen it, and I told them I was going to get the principal in here to search them, and I had one student in particular that was very worried about the search. He did not have my pen. I think he was worried about whatever else is going to be found in his book bag. He's like, y'all give the pen back now. If you've got the pen, you better give it back. It was folded up in my book. They had not stolen it, but they did know where it was at, because they, like one kid, Miss Hyatt, open your book. They let us, we searched for like 30 minutes. So, that'll do good enough. All right. Okay, questions here? All right, so let's look at another problem. All right, so for this one, we want to find the average value of f on the interval from -4 to 4. And I'll tell you, these are line segments. That is a semicircle. A better written problem would tell you that. So this becomes a little bit more difficult to think about. To me, it's a little bit easier to think about with something like velocity, because we're already familiar with how to find velocity. We know velocity is change in our distance over our change in time. So think about what we did here. My average velocity was my change in distance, which was the integral of velocity, divided by time, right? So for this particular function, my average f of x, like I don't even know what that stands for, it's just a function, right? The average velocity, or the average value of f of x is going to equal our change in the integral of f, which would be our change in our capital F of x over our change in time. Now, to find how much that capital F of x has changed, we can integrate our f of x, right? So the way I can set this up is it's going to be the integral from -4 to 4 of f of x dx over our change in time, our t, or I guess it's x in this case actually, but because this is our x right here. And then our x, we're going from -4 to +4, so that would be 8 in this case, or you could subtract your endpoints there. Now let's think about why this is going to work, although it's not like how we're going to do the problem. The reason it's going to work is because when we integrate lowercase f, we would get capital F, and then we would evaluate that from -4 to 4. So this would be capital F of 4 minus lowercase f. I'm messing this up bad. Redo this. Capital F of 4 minus capital F of -4. So that's going to tell you how much that changes. However, this is not how we're going to be able to actually solve it, because we don't know what capital F is, nor can we find it. To find the integral from -4 to 4 of f of x, we are just going to use volume formulas. I mean, not volume, area formulas. So I would just break this up. In fact, I'd probably do it like this on this one. And just do, this would be 9. This would be 2. This right here would also be 2. This would be 1. This would be 2. And then this one is going to be 1/2 of pi times 1 squared. So you'll get 1/2 pi. So if we add all of those together there, if we add all of that area together, we are going to get 9, 14, 15, 16. 16 plus 1/2 pi divided by 8 here. And they might like simplify that a little bit so you don't have fraction inside a fraction. You could love connection that one. You'll get 2 plus 1 over 16 pi. They'd probably write it like this actually, pi over 16. Something like that. Okay, questions? All right, so no matter what they are asking you for, okay, no matter what they ask you for, average value of whatever function, so let's just call it average value of f of x, is going to equal 1 over b minus a. This is just the length of interval that you're looking at. So in this case, it was that -4 to 4, which gave us 8, times the integral from a to b of f of x dx. So this is going to be the case for any average value problem. So if they ask you for the average velocity, you would have 1 over b minus a times the integral of velocity. So what you should notice here is, like, sometimes it seems kind of backwards, but if you're finding an average value, it's going to be the integral of that same function. All right? So if you want average velocity, you do 1 over b minus a of the integral of velocity. If you want average position, then you would do the position formula here. If you want, it may ask you for, like, you have the, a tank is filling up, you know, at this particular rate. You would, if it wants to know the average rate at which the tank is filling up, 1 over b minus a of the integral of the rate that that tank is filling up. So whatever it's asking you for, this is the formula you'll use every time. There. So, oh, I didn't realize that was what was here. I thought that was a problem. So this is just stated for you again. I guess not. I'm gonna make you one more problem. We need to do one more thing. One that you sometimes will see. All right, I'm gonna make a chart, and we're gonna have x is 0, 1, 2, 3, and let's do f of x is 4, 7, 9, 11, and find the average value of f prime of x on the interval zero is less than or equal to x less than or equal to 3. And it probably would give you some information like f is a differentiable function here or something like that. So, average value of f prime on the interval from 0 to 3 if we were looking for average value, we would be doing 1 over 3 minus 0, or just go into 3, times the integral from 0 to 3 of the function that they're asking us for average value for, f prime of x dx. But they don't give us f prime here. We don't have any information about f prime. So how do we go about solving this? What? Okay. Okay. When you integrate f prime, what do you get? F. So what's happening here is you got 1/3 times f of x evaluated from 0 to 3, right? Which is 1/3 of f of 3 minus f of 0, right? Because this right here means your change in f from 3 to 0. That's what it finds. And so then these values can be pulled from the table. So 1/3, 11 minus, what was it, 4? Which does give you 7, so you get 7/3 for that. So the way that you evaluate this part can be different. If it is given to you from a graph, a lot of times you're actually like using equations to find the, using equations for area to find the actual area under the curve. If it's given to you from a chart, you might be pulling numbers from the chart. You actually go ahead and integrate this. It could be given to you with an equation, in which case you would actually integrate this equation and find that value, right? So it can be done several different ways. I've seen it both places. This is something that could show up either place. You have to write out this, and the only step that you could skip on this one is this step. You could skip that. But if it shows up on FRQ, you need to show your setup right here, because a lot of times that setup gets you the majority of your points. If you just go straight to the answer, you may get nothing. And then you need to show how this converts to be an f of 3 minus f of 0. You could leave this out in the middle if you would like. And then you need to show where you get those numbers right there. I mean, maybe they would let you skip this step, but I wouldn't. Because depending on the problem, you might get points for putting those numbers in correctly. So, to be on the safe side, and because it would not be worth it to not get college credit for this class because you did not want to show your work, I would show most of this. I feel pretty confident you can skip this step. I'd put everything else for that. Okay? Alright, so, let me see what we got here. Worksheets today. I think we're there.